Today we will be talking about characteristics of quadratic graphs by Henry Crandall
and Jacob Anderson.
First, what is a quadratic function? And the answer is quite simple. It is any function whose degree is 2. So anything with x squared. Notice this is the key.
The general form for a quadratic function is ax squared plus bx plus c. Notice the x squared.
These are the 5 characteristics that we will be talking about today: increasing, decreasing, domain, range, and extrema.
When looking at a quadratic function and seeing if it's increasing or decreasing, make sure to look left to right. If the slope is greater than 0, the quadratic function will be increasing. If the slope is less than 0, the quadratic function will be decreasing.
Here we have an example graph. For this graph, it is increasing from 0 to infinity, and it is decreasing from negative infinity to 0. The next characteristic we will talk about is domain. The domain is defined as a set of x values for a function. It can be easily thought as how far left does the graph go and how far right does it go. Remember that the domain corresponds to the x values or the x coordinates of the graph.
Here we have the function f of x equals x squared plus 3. Notice that for this function, you can plug in any value of x and it will never be undefined. Because of this, the domain is from negative infinity to infinity.
The domain for quadratic equations is really easy because it's always negative infinity to infinity, because no value of x will ever make the function undefined. See, it's always negative infinity to infinity.
The next characteristic of quadratic functions we'll be discussing is range. Range is defined as the set of y values for a function. Range can also be thought of as how low and how high the graph goes.
In this example, we will be using the same graph of x squared plus 3. On this graph, the y-coordinate never dips below y equals 3, and it goes up to infinity. So the range for this particular graph would be 3 to infinity. While the domain was always negative infinity to infinity for any quadratic function, the range will vary for each quadratic function.
The next characteristic of quadratic functions we'll be looking at is extrema. This is defined as the maxes or min of the graph.
A max can be thought of as the top of a hill, and a min can be thought of as the bottom of a valley. This example, we'll be looking at this graph over here for the graph of the equation x squared plus 3. The only extrema on this graph is a minimum located at 0, 3. This is a minimum value because it is the bottom of a valley. Be careful when describing extrema. The vocabulary used is very important. For example, for explaining the minimum value on this graph, you would say there's a min at x equals 0. The minimum value is 3. That's it. Hopefully you learned something new today.